the errors we are getting on the CAN protocol. So that is the errors. So on the bus errors handling concept, you can write down bus error handling concept. Okay. So what is the error in the CAN bus? So it occurs in various factors. It includes due to the transmission. So of the high and low, the CAN high and CAN low, uh, there will be the electric force will be created, right? So as we know, whenever there is a rising of the voltage, okay, so whenever the ideal condition, it is a 2.5 the voltage. Okay, so and this is also 2.5. Whenever it rises here, it will rises to 3.5 voltage and it will be rise to 1.5 voltages. So remember, whenever it is rising, the difference of the voltage is 2 volts. Okay, so this will be the dominant. So whenever the difference is zero, right? So the difference is means this is a can as we discussed, can high minus can low. Okay, so if it is a 0 volts, it will be a recessive one. If it is a 2 volts, it will be a dominant. So this is what we discussed previously. So now uh, whatever the voltage, it will changes, and even it will get a noise will be added. The because of that voltage, the errors will be triggered. So errors will be triggered based upon the electrical noise. And fault nodes means whatever the ECUs. Suppose in the CANBus network we have the nodes, so the data, it should be transferred from specifically from a master to the slaves of the network. So if this slave is not responding properly, that is a fault node. And hardware malfunction means whatever the drivers, the can it have the data to be sent on the network. So that will be the hardware malfunction. If any hardware is getting filed, so that time we'll get the error. And protocol violation, so means whatever the rules as we discussed earlier. So if the rules not able to follow the protocol, like sending of the messages in one after the another, and it should not be overlooked, it should have some delay between the messages. So like we should follow. If you are not following, then we'll get some errors. Okay, so now you can write a notes. So errors in the CANBus can occur due to various factors, like including electrical noise, fault nodes, hardware malfunction, and protocol violation. So protocol violation, it includes uh, the software messages and signals, software messages and signals incorrect. You can make it like this. Next, it have 5 different types of error handling in CANBus. Okay, so there are CRC error. So as we know the frame format of the CAN, so we have a startup frame, identifier, RTR, control field, data field, CRC field have the CRC delimiter, CRC slot, acknowledgement field have the acknowledgement slot and acknowledgement delimiter, and end of frame. So, and CRC, it will come on CRC error will be verified towards the CRC slot. Acknowledgement slot, we have the acknowledgement error will be identified. And towards the data transmission from start of frame to until CRC, there will be the stuff error, means what are the bits we are making, transmitting, that will be stuff error. And the format error, so whatever the data we are able to transfer from the CRC and acknowledgement field, end of frame, if the sequence is correct, then we'll get a format error and bit level error. So whatever the data we are transferring, so that 88 bits. So if 88 bits should follow 1010, some like similar sequence. If any one of the bit is changed to 1 to 0, So that case, that bit error will be identified. Okay, so let's discuss in detail about each and every error frame format. So the these five different types of errors will be getting on two levels. First one is the message level. So message level will get a the form error, and next is CRC error and acknowledgement error. So these are the on message level we'll get, and bit level we'll get. So ones and zeros on the bit level we'll get bit stuffing error, bit error, or bit monitoring error. So we can call as a bit error or bit monitoring error. So these are the another two types. So totally, like these are the five types of error. So these five types of error are splitted as two ways. So one is message level, and other one is the bit level. So message level we have three types. Bit level we have a two types. Is it clear? Vardhan Chakravarti.
Yes, sir. Clear.
Okay. Receiver side, uh, we are transmitter side is one who are transmitting the data. Okay, and receiver is the one who receives the data. Okay, so you can write down message level. On message level we'll discuss about message level, because so here we have we told that message level will have the form error, CRC error, and acknowledgement error. We'll discuss about the message level and form error, individual errors. Okay, so message level you can write down message level form error, form error, FORM error, form error. So when this error will be occurred, so you can write down when you know about the frame format, right? So in the frame format, whenever the acknowledgement delimiter, okay, so on CRC delimiter and end of frame. Okay, so acknowledgement delimiter will be one, CRC delimiter will be one, end of frame will be always ones, 7 ones. Okay, if any one of this bit is changed to 0, ఓకే, ఏదైనా ఒక్క బిట్ గాన చేంజ్ అయిందంటే అప్పుడు ఈ ఫార్మ్ ఎర్రర్ అనేది వస్తుంది. సో రిమెంబర్, ఫార్మ్ ఎర్రర్ is nothing but acknowledgement delimiter, CRC delimiter, end of frame, bits is fixed format. It is always fixed format. సో మెసేజ్ లెవెల్ ఎర్రర్, ఈ ఫార్మ్ ఎర్రర్ ఎవరు ఐడెంటిఫై చేస్తారు? హూ విల్ ఐడెంటిఫై? వెదర్ ద రిసీవర్ ఆర్ ద ట్రాన్స్మిటర్? సో రిసీవర్ విల్ ఐడెంటిఫై ద ఫార్మ్ ఎర్రర్. మనం ఏదైతే డేటా సెండ్ చేస్తున్నామో ఆ డేటా అనేది వ్యాలిడా కాదు దాన్ని రిసీవర్ ఎండ్ వెరిఫై చేస్తుంది. సో ఇఫ్ ఎనీ వన్ ఆఫ్ దిస్ బిట్ ఈస్ చేంజ్డ్ 1 to 0, then it will be got a form error. Okay, so you can write it down. Form error occurs when node detects invalid CAN frame format. Okay, so this can happen if node send a frame with incorrect number of bits, or frame format violates the CAN protocol specification, then we'll get the form error. Okay, so generally if it will be identified by the receiver end. If a receiver finds that any of these bits are invalid logical level, then receiver detects this is a form error. Okay, so the important for is, so startup frame, whenever we are sending the data, it always startup frame will be G1. Okay, so means it will be a 0. 1 bit startup frame must be dominant always, when the entire end of frame must be recessive. So remember, like startup frame లో మనకు 0 అనేది ఉంటుంది, and end of frame లో ones అని ఉంటుంది అనమాట. సో 7 ones. Okay, so and acknowledgement delimiter, CRC delimiter must be recessive. So acknowledgement delimiter and CRC delimiters must be recessive. Ivanni once untadi. If any one of these bits changes, then we'll get a form error. You can write it down. Form error. Form error. The acknowledgement error, you can write down this format. Acknowledgement delimiter, CRC delimiter. So CRC delimiter and end of frame is always recessive. మీ recessive అంటే 1 అన్నమాట. always recessive while is always recessive while data transmission is happening. While data transmission. Okay. So next point, if any one bit is changed from if any one bit is changed from recessive to dominant, then it forms form error. Okay. So if interviews, they will ask you what is a form error, you need to explain that. So form error, okay, so form error is nothing but acknowledgement delimiter, CRC delimiter, end of frame is always recessive when data transmission, If any one bit is changed from one recessive to dominant, then we'll get a form error. Like that, you should explain. Is it clear? And write down another point. So form error will be identified by receiver on message level. This is one more point you should write down. These are the 2 points for important. The first point you need to give this, and second point is to understand you this point. Is it clear? What is the message form error? Did you complete the notes? Vardhan, Anil?
Done, sir.
Okay. So these are some other points to understand in detail. Okay. So next is write down CRC error. So the CRC error is identified by receiver. Okay. So like CRC slot we have. So with the help of the CRC slot, whatever the data we are transferring is correct or not, it will be verified on CRC slot. Okay. CRC value, write down CRC error. CRC value is in CRC slot. CRC value is not matched. Transmit not matched. Transmitted value is X and received value is Y. If in CRC slot, CRC value is not matched, transmitter value and receiver side, you can write down. In CRC slot, CRC value is not matched, transmitted side and receiver side. So then we will get CRC error. Then we'll get the CRC error. Okay, so like that we should you should write it notes. Okay, so like we have the transmitter side CRC slot, and receiver side we have the CRC slot. So whenever the data like transmitting and receiving side is not matched, then we'll get the CRC error. So as we know, CRC means cyclic redundancy check. Okay, the full form of CRC is cyclic redundancy check. This is a CRC. So it have a 15 bits. As we know, CRC slot, we have the 15 bits information. Okay, in the frame, okay, మనకి ఏదైతే ఫ్రేమ్ లో సిఆర్సి స్లాట్ 15 బిట్స్ ఉంటుంది కదా, ఈ 15 బిట్స్ అనేది క్యాలిక్యులేట్ చేస్తుంది. సో డేటా మనం సెండ్ చేసినది రిసీవర్ సైడ్ ట్రాన్స్మిటర్ సైడ్ కరెక్ట్ గా ఉందా లేదా అనేది వ్యాలిడేట్ చేస్తుంది. సో వన్స్ ట్రాన్స్మిటర్ సైడ్ నుంచి డేటా అనేది రిసీవర్ సైడ్ ఇన్కరెక్ట్ గా ఉంటే అప్పుడు సిఆర్సి ఎర్రర్ అని వస్తుంది. సో who will identify this CRC error? Receiver will identify the CRC error. You can write down this CRC error will be identified on receiver side. CRC error will be identified on receiver side. On receiver side, it's enough. Okay, so receiver side, you can write it down. On this is on message level only. Okay, so on message level, you can write down on message level. So the transmitter has calculated the CRC value, added to the message, and every receiving node also should calculate the CRC. Okay, if this transmitter files doesn't matches the transmitter side and receiver side, then we'll get the error. Okay, so if the receiver CRC calculation doesn't match the transmitter CRC, the receiver will detect a CRC error. So this is a one important point you should write it down, and these are the important points you should understand. Okay, so this is about the CRC error. Okay, is it clear? If someone asks you what is a CRC error, if the receiver on the receiver side, the CRC error will be identified. Okay, so transmitter side of the CRC and receiver side of the CRC is not doesn't match the data, then we'll get the CRC error. Okay, so understand the concept, you can derive your own definition. Okay, is it clear? Any doubt on this topic? When CRC error will be getting on the CRC slot? Okay, hope you are able to understand this concept. So as I told you, like internally the ECU have the CRC have the calculations. Okay, the XR calculation. So the transmitter, it will able to identify what is the data you were able to send and what is the data it able to receive. So both can be validated on the receiver and transmitter side. Okay, so this is about the CRC error. So like we discussed, two types of errors. What are the two types of errors?
Form error and CRC.
Form error and CRC error. Okay, now we need to discuss about acknowledgement error. Okay, who will identify? So as a part of the master, means the transmitter will send the data to the slave. Okay, so slave will receive the data. Okay, whether the data మనం ఏదైతే డేటా సెండ్ చేసామో ట్రాన్స్మిటర్ సైడ్ నుంచి రిసీవర్ కి, ఆ డేటా అనేది మనకు రిసీవ్ అయిందా లేదా ఎఫెక్టివ్ గా అని మనం వెరిఫై చేయాలన్నమాట. So that is a part of the acknowledgement. ఓకే, సో ఈ డేటా అనేది మనకు రాకుండా ఉంటే డేటా సెండ్ చేసాము బట్ అక్నాలెడ్జ్మెంట్ అనేది రిసీవ్ అవ్వలేదు. సో దెన్ విల్ గెట్ ద అక్నాలెడ్జ్మెంట్ ఎర్రర్. ఓకే, సో యు ఆర్ ఏబుల్ టు సీ there is a the data it able to transfer. Here it is acknowledgement slot, it have the 1. When it is coming to the no acknowledgement, it will be a 0. Okay, so like the transmitter is expecting some response from the receiver. Okay, so you can write down acknowledgement error. So the acknowledgement error, acknowledgement error, acknowledgement error, ACK I will write like acknowledgement, sorry, acknowledgement error will be identified by transmitter, identified by transmitter side on message level, Okay, so this is the one point you should write it down. So means whatever the acknowledgement, it will be identified by the receiver, and from the whatever the data we are able to send from transmitter to the receiver, so the transmitter will wait for the acknowledgement. So that acknowledgement will, if I am not able to receive the acknowledgement, then transmitter will say, okay, you are not giving the response to me, it is a acknowledgement error. So like that the transmitter will give the acknowledgement error, saying that I didn't receive the information. Okay, so acknowledgement not received from the receiver to the transmitter after the message sent, then we will get the acknowledgement error. So that will be based on the acknowledgement slot. Okay, so acknowledgement error occurs when a transmitting node doesn't receive a acknowledgement from any receiving node during the acknowledgement slot. You can write down acknowledgement error occurs. Acknowledgement error occurs when transmitting node doesn't receive an acknowledgement from any receiving node, because I am saying in terms of the networks, the ECUs that we are connecting it. Okay, multiple ECUs connect అయినప్పుడు ఏ ఒక నోడ్ నుంచి మనకు అక్నాలెడ్జ్మెంట్ అనేది రాకుండా ఉంటే అప్ టు acknowledgement. In case like we have a 2, then we can say receiving node. Okay, so any receiving node during the acknowledgement slot. Okay, so acknowledgement, you can write down the another point, acknowledgement not received from transmitter to receiver after message sent. Acknowledgement not received from receiver to transmitter after message sent, then we'll get the acknowledgement error. Is it clear? So in CANTrace we can see like this. Okay, so మన CANTrace లో మనం ఎర్రర్ ఏదైతే ఉంటుందో, సో మెసేజ్ సెండ్ చేసాము, ట్రాన్స్మిటర్ సైడ్ నుంచి ఎర్రర్ అనేది డిటెక్ట్ చేస్తుంది. సో వాట్ టైప్ ఆఫ్ ఎర్రర్? ఇట్ ఈస్ నాట్ అక్నాలెడ్జ్డ్, అక్నాలెడ్జ్మెంట్ లేదు అనేసి మనకి ఈ ఐడెంటిఫికేషన్ అనేది వస్తుంది అన్నమాట. ఇట్ ఈస్ ఇన్ ద లైక్ నాట్ అక్నాలెడ్జ్డ్ ఎర్రర్, సో దట్ ఈస్ ద acknowledgement error. Is it clear? So in that trace CANoE trace window, we will get this type of error. You are able to understand this? What is acknowledgement error? Who will identify the error? And how we are able to trace the error? Okay, is it clear? So like this in the acknowledgement slot, it will be varied. Okay, these are a microcontrollers. Okay, so inside it is having the microcontroller in it. Okay, so next go to the other topic of bit level. Okay, write down bit level. So bit error will be identified by receiver. Okay, identified by receiver. Receiver on bit level. On bit level. So you are able to see here, the bit is 0 here and the bit is 1. So it is a transmitted. When the data is transmitted due to some electrical related EMF related or some noise or some because of some fire loads, maybe something, we don't know the reason. So because of that, the internally the bit value is changed 0 to 1. So the receiver and the transmitter side and receiver side, the bit is not matching properly. So then that we call as a bit error. Okay. So now write down the definition of this. So if interviews they will ask you, you need to clear on the pen. Okay. Bit error occurs when received bit when received bit doesn't match the transmitted bit during the bit synchronization phase during the bit synchronization phase then we'll get the then we will get the bit error So this is a very important point you need to give in the interview. If what is a bit error if they ask you. Okay, is it clear? So this can be happen because of the electrical noise or signal reflection or improper termination, whatever the 120 ohms, if it is not working properly, then and that is also one reason it got spoiled because of some short circuit or anything that can happen internally, the electronics thing. So during that time, whatever the transmitting and receiving side, the voltage sinking is not happen accordingly. So then we'll get the bit error. Okay. So the important point is this bit error. Okay. And if parallel, you can draw this block diagram. Okay. So whatever each and every bit level means, you can draw this bit is 0 and bit 1, whatever the points I'm giving. So you can make it parallelly, this block diagrams also. Okay. Is it clear? Next is a bit stuffing error. This is a very, very important topic. Most of the interviews, you will get this information. Okay, here you need to remember what is a bit stuffing. So then you need to understand what is a bit error. Okay, so the transmitter side, you can write down the bit stuffing error. Bit stuffing error. Bit stuffing error. Bit stuffing error will be identified by receiver on bit level. Receiver will identify. Okay, so like we have a the 6, imagine there are 5 bits or ones. 6th bit you can see there is a 0. Okay, so it whenever the syncing is happening, okay, so like the bits, whatever the bits you are able to 1, 2, 3, 4, 5. Sixth bit should be the stuffing bit. Okay, always sixth bit should be the stuffing bit. We usually say this whatever the data you are able to transfer 1 1 1 1 1, and this sixth bit is the stuffing bit. Okay, so this is a 0. So in case this stuffing bit is not changed, okay, so this stuffing bit is 0. So instead of 0, like receiver end, it receives the 1. Then it is called the bit stuffing error. Okay, if transmitting side is 1 1 1 1 0 and receiving side is all that sixth bit is like it is not changed, it is the same order, then we'll get the bit stuffing error. So you are able to see this block diagram. So in bit stuffing means always the sixth bit should be the differ. Okay, if you see here 1 to 5, it will be a 0, and sixth bit will be the high. Okay, and similarly, like 1 to 5, it will be high, and sixth bit will be low. Means not only the bit stuffing here, uh, instead of ones, it will be like a zeros also. Whenever this 5 bits should be low and the other one is high, means this 6 bit which should be high, దీన్ని మనకు bit stuffing అంటాం అనమాట. And parallelly it can be also like this. So like ones, and the sixth bit will be a 0. So it should happen. Okay, దీన్ని మనకు స్టఫింగ్ అనే అంటాం అనమాట. బిట్ we call as a bit stuffing. Okay, so usually it should happen. మనం ఇది డైరెక్ట్ గా మానిటర్ చేయలేము ఈ ఎర్రర్స్ ని. విత్ ద హెల్ప్ ఆఫ్ సమ్ ఆస్లోస్కోప్స్ we can monitor it. Okay, so on bus level, but as of now just we need to understand the concept. సో మనకి ఎప్పుడైతే ఈ డేటా ట్రాన్స్మిటర్ సైడ్ నుంచి డేటా వెళ్తుంటుందో, ఈ డేటా అనేది సింక్ బిట్ స్టఫింగ్ అనేది యాడ్ అవుతూ ఉండాలి. ఇఫ్ దిస్ బిట్ స్టఫింగ్ ఈస్ నాట్ హ్యాపెనింగ్, like imagine like this is the data we are sending. So if it is continuous like 0 0 0 0 0 6 zeros, so instead of ఇక్కడ మనకు 1 రావాల్సింది 0 అనే యాడ్ అయిందంటే then it will be the bit stuffing. So ఇక్కడ bit stuffing ఉంది. సో ఇక్కడ ఎర్రర్ అనేది క్రియేట్ అయింది అనమాట, bit stuffing error. Okay, hope you are able to understand. If you not understand, let ask me, we'll discuss. Okay, so similar గా ఇక్కడ మనకు 5 bits high ఉంది. ఈ 5 bits కూడా మనకు 6 bits, ఐ మీన్ ఇక్కడ 0 అని చేంజ్ అయింది, ఇక్కడ మనకు 0 అనేది రాలేదు. సో 1 అనేది ఉంది, అలాగే ఉంది. కాబట్టి ఇక్కడ కూడా బిట్ స్టఫింగ్ ఎర్రర్ అనేది ఫామ్ అయింది. Okay, let's understand what is a bit stuffing. Okay, so bit stuffing is it is used for resynchronization of the data transmission. Write it down, bit stuffing. So definition of bit stuffing: bit stuffing is used for resynchronization of the data transmission. When transmitter encounters 5 consecutive bits, means encounters means it sends, when transmitter sends 5 consecutive bits of same values. So same values means you can see these are the same values in the data being transmitted, either 5 consecutive bits of whether it will be a ones or zeros. Now we can see it is a ones, so sometimes it will be zeros also. Okay, 5 consecutive bits means that is a sequence of bits, 5 consecutive bits and of zeros ante continuous 5 bits zeros anamata, 5 bits ones. Okay, you can write down, it is used for resynchronization when transmitter encounters a 5 bits of same value in the data being transmitted, either 5 bits consecutive bits of 0, whether 5 consecutive bits of ones. Okay, it automatically, next point or continuation you can write down, and it automatically insert extra bit, it automatically insert extra bit of the opposite value, of the opposite value, of the opposite value. Means this is ones, right? ఇక్కడ ఏదైతే వన్స్ ఉంది కాబట్టి ఆపోజిట్ వాల్యూ ఏమవుతుంది, 0 అవుతుంది బిఫోర్ కంటిన్యూ ట్రాన్స్మిటింగ్. సో ఇక్కడ ఏదైతే మనకు వన్స్ జీరోస్ అని సీక్వెన్స్ ఫామ్ అయితే అప్పుడే మనకు డేటా అనేది ఎఫెక్టివ్ గా ట్రాన్స్ఫర్ అవుతూ ఉంటుంది, ఫర్దర్ గా సింక్రొనైజ్ అవుతూ ఉంటుంది. సో లైక్ 1 2 3 4 5 6 మళ్ళీ అంటే స్టఫింగ్ బిట్ అన్నమాట. మళ్ళీ 1 2 3 4 5 6 మళ్ళీ స్టఫింగ్ బిట్. ఇలా డేటా అనేది సీక్వెన్స్ గా వెళ్తూ ఉంటుంది అనమాట. ఓకే, ఏదైతే మనకు మెసేజ్ లో బిట్స్ ఇన్ఫర్మేషన్ ఉంటుందో. ఓకే, సో దిస్ ఈస్ అబౌట్ బిట్ స్టఫింగ్. యు ఆర్ ఏబుల్ టు అండర్స్టాండ్ వర్ధన్ చక్రవర్తి? Anil, what is bit stuffing? Any doubt on this topic?
No.
Okay, now we need to understand about what is a bit stuffing error. Okay, so this is a very important definition you need to know. Don't get confused. Bit stuffing is used for resynchronization of data transmission. That is what you need to say in interview. Okay, so what happens, bit stuffing, it will have a 5 consecutive bits of ones and zeros. So on the 6th bit will be the it will insert the opposite, okay, of the continuous transmission. Okay, that is the extra bit. Okay, so you can write down bit stuffing error. Bit stuffing error. If in interviews, if they ask you what is bit stuffing error, you can give this information. If sequence of 6 bits of same logic level, 6 bits of same logic level means whether it is a ones, 6 ones, or whether it is 6 zeros. So sequence of 6 bits of same logic level is observed on the CANBus, is observed on the bus within the CAN message, within the CAN message. So sometimes they may ask you, do you know like where from on what basis you were able to say the bit stuffing is? So it is between the start of frame to CRC field. Okay, until this only you are able to consider the bit stuffing area. So ఇది మాత్రం మనం bit stuffing area అని మాత్రం కన్సిడర్ చేస్తాం. Sometimes they will ask you. Okay, so this you can write down on the CANBus. So that's it. Okay, this is a very important point, and you can extension of this CAN message between start of and CRC field. The receiver who will detect this bit stuffing error, the receiver will detect the bit stuffing error. So that we already know this point. Okay, so here the important point is, what is a bit stuffing, what is a bit stuffing error, where in on which area the bit stuffing error will be identified. So the bit stuffing error will be identified on start of frame, identifier, and RTL, ID, DLC, data field, CRC field. Until this area, this is the bit stuffing area. Okay, is it clear on bit stuffing error? So on can we trace how we'll identify this error? So we'll get like this bit error. So the code will get, and the receiver side error it is, and in the error we can see that is a bit error. So on the trace window we can see it is a bit error and bit stuffing error. So you can see that bit stuffing error, stuff error it will be. So this will be identified by the receiver side. You can see the code, that is a stuffing error. Okay, bit stuff error. So these are the bit errors and stuff errors that you will identify them on the trace window. Is it clear? Sorry. So
Yes,
now the important, whatever the errors we discussed, just a brief summary. So the bit error, it will be identified by the transmitter. So, okay, what is a bit error? The node which transmitter side and receiver side, it is not same, then it will be called as a bit error. Bit stuffing error, if the sequence of 6 bits have the same logic level between the start of frame and the CRC, then we'll have a bit stuffing error. Form error, it will be the end of frame and acknowledgement delimiter and CRC delimiter have the same, it should be always recessive. Okay, if any one of the bit is changed to 0, then will be called as a form error. And acknowledgement error, so acknowledgement error will be identified by the transmitter end, So if the transmitter not able to receive the acknowledgement from the receiver, then we'll get the acknowledgement error. And CRC error, cyclic redundancy check. So whenever the transmitter message and receive